Hello everyone, welcome back to ng.classes. I hope you all like my previous video, and if it helped you, please do subscribe my channel. And yes, if you want me to discuss any other topic, please comment in the comment box. So today we are going to discuss rational number. What is rational number? Any number which can be represented in the form p by q, where q not equals to 0 and p and q both are integers. Such fraction or such number are called rational number, or in other words we can say any fraction with non-zero denominator is a rational number. So any fraction in the form p by q where q must not equals to 0, denominator will never be 0, and p and q both are integers. Such fraction are called rational number. Let's take few example. 5 by 4. Here this 5 as well as this 4 both are integer and denominator definitely is not 0. So we can say 5 by 4 is a rational number. Similarly 2 by 3. This one is also a rational number. Now if I am taking a whole number, that is 24, whether it's a rational number or not, yes, this 24 is also a rational number. Why? Because we can represent this 24 as 24 by 1 in the form of fraction. So this 24 is also a rational number. Now what about 0? Whether this 0 is a rational number or not? Yes, this 0 is also a rational number. Why? Because we can write 0 as 0 by 10 or 0 by 25. So 0 is also a rational number. Numerator can be 0, but denominator, that is q, must not be 0. Because in mathematics, if any number having denominator as a 0, that means not defined, or infinity. So we will not consider this case for rational number. Clear? Now just see this figure carefully. What you can see, capital N, capital W, Z and Q. What are these letters representing? Here capital N represent natural number, W represent whole number, Z represent integer and Q represent rational number. Okay, now in your previous class you have gone through the concept of natural number, whole number as well as integer. So what is natural number? All the counting numbers starts from 1 are natural number. What about whole number? All the counting numbers starts from 0 a whole number, and we can see clearly that whole number will include natural number as well, which is true, right? What about integer? Integer we usually represent on number line, where 0 is the midpoint, and on the right hand side it will be increasing like positive 1, positive 2 and so on. And on the left hand side it will be decreasing like negative 1, negative 2 and so on. So integer are all the number with positive and negative sign, as well as 0 is also integer. Okay, so here you can see clearly that integer will include natural number as well as whole number, which is true, right? Now rational number. So rational number will include natural number, whole number as well as integer. Because you know, if I am taking an integer positive 25, we can write it as 25 by 1. So this is a rational number, right? So all the natural number, whole number and integer are rational number. Apart from this, all the fractional numbers are also rational number. Only one condition we will follow, that is denominator, that is q, must not be 0. And now we will discuss few properties of rational number. Here we are having 4 property, that is closure property, commutative property, associative property and distributive property. One by one we will discuss each property in detail. So let's start from closure property. Here we will discuss closure property of whole number. Why whole number? Because you have already covered whole number and we will start from whole number and will connect it to rational number. So let's take 4 operations of mathematics, that is addition, subtraction, multiplication, and division. At first we will check for addition whether closure property hold or not. So randomly I am taking any two whole number, suppose 5 and 8. Now let's add it. So 5 plus 8, it will be 13, right? So what I am getting from here, that if I am adding two whole number, my answer is also whole number. So whole number is enclosing everything, the questions part as well as the answers part. It is closing everything. So we can say whole numbers are closed under addition. Randomly, when you will take any two whole number and will add it, definitely your answer will be whole number. So now let's check the same thing for subtraction. Same two whole number I am taking here and subtracting now. What will be the answer? -3, which is not a whole number. Okay, so when I am taking two whole number and subtracting it, my answer is not whole number. So whole number is not closed under subtraction. It's not closed under subtraction. Okay, randomly when you will take any two whole number and will subtract it, maybe few time you will get whole number but not all the time. So it's not, we are talking about like always what you will get. So it's not closed under subtraction. Now multiplication, 5 and 8, multiply it, we will get 40. So when we will multiply two whole number, our answer will be whole number only. Okay, so yes, under multiplication, whole numbers are closed under multiplication. Okay, now do it for division. What we'll get? 5 by 8 or a decimal number, which is like definitely not a whole number. So whole numbers are not closed under division. So it's not closed under division. Whole numbers are closed under addition and multiplication and not closed under subtraction and division. And now closure property for integer. We'll do the same thing for integer. So the operations addition, subtraction, multiplication, and division. So let's take any two integers. I am taking -2, -2 and -3. Okay, now add it. So -2 I am going to add, with -3. What we'll get? -2 minus 3, which will give us -5. Okay, so when I am adding two integer, my answer is integer only. So yes, integers are closed under addition. Okay, now let's check for subtraction. -2, -3. Subtract it and we will get -2, +3, 1. So when I am subtracting two integer, my answer is also integer. Okay, so it's closed under subtraction as well. Yes, it's closed under subtraction. Now what for multiplication? -2 and -3 we are having. Multiply this. We will get 3 2 times 6, negative, negative, positive. So it's closed under multiplication as well. 6 is a integer and yes, it's closed under multiplication. Now what about division? Divided. We will get 2 by 3. Okay, minus minus will cancel each other and we'll have 2 by 3, which is a fractional number and not an integer. So this one is not integer and integers are not closed under division. So it's not closed. So for addition, subtraction and multiplication it's closed, and for division it's not closed. Okay. Now closure property of rational number. So we will take any two rational number, like for the same 4 operation, addition, subtraction, multiplication, and division. Now let's take any two rational numbers. Suppose I am taking 3 by 8 and minus 5 by 7. Add it. 3 by 8 plus minus 5 by 7. LCM will be 56. Here we'll get 21 and then negative sign, yeah, then we'll open the bracket and then 40. So minus 19 by 56, which is a rational number. So when I am adding two rational number, my answer is also a rational number. So I can say rational numbers are closed under addition. Yes. Okay. Now let's do the same thing for subtraction. 3 by 8 minus 5 by 7. 56, 21 plus 40. And we will get 61 by 56, which is a rational number. So I can say rational numbers are closed under subtraction as well. Yes. Okay. Now let's do the same thing for multiplication. 3 by 8 into minus 5 by 7. And we will get minus 15 by 56. Which is also a rational number. So we can say when we are multiplying two rational number, our answer will always be a rational number only. So yes, rational number are closed under multiplication. Now let's do it for division. 3 by 8 divided by minus 5 by 7. Divide it. 3 by 8 into 7 by minus 5 and we will get 21 by minus 40. So here also we are getting rational number, but it will not true for all the cases. Suppose I am taking another two pair of rational number. The first one 3 by 8 only, like the previous one, and the second one 0. So when we will divide it, 3 by 8 divided by 0. Now recall the concept of rational number, the definition. 0 can't be the denominator. Q will never be 0. So here we will conclude that for division it will not closed. Okay, just for this exception. Okay, like just because of this exception it will not close for division. And now we will discuss our next property, that is commutative property. At first we will discuss it for whole number. So let's take any two whole number. I am taking 3 and 9. Now add it. 3 plus 9 is equals to 12. What about 9 plus 3? This one is also 12. So can I say 3 plus 9 is same as 9 plus 3, which is 12. So when I am changing place of 3 and placing it at 9's place and changing place of 9 and keeping it at 3's place, my answer is same. This property is called commutative property. When the left number is commuting to the right's place and right one is commuting to left's place. If such thing is happening and at last if you are getting the same answer, then we can say addition is commutative. For whole number. If I will not get the same answer, then I can say it's not commutative, like addition is not commutative. Or if I am not getting for subtraction, I can say subtraction is not commutative. Okay, let's check for subtraction. 3 and 9. 3 minus 9 will be negative 6. And what about 9 minus 3? It will be positive 6. So both the answer 3 minus 9 is not equals to 9 minus 3. So subtraction is not commutative for whole number. Clear? Let's take for multiplication. 3 into 9. 27, right? What about 9 into 3? This will also be 27. So we can say 3 into 9 is same as 9 into 3. So yes, multiplication is commutative. Now check for division. 3 divided by 9. We will get 3 by 9 or 1 by 3. What about 9 divided by 3? We are getting 9 by 3, that is only 3. So 3 divided by 9 is not same as 9 divided by 3. So division is not commutative. Now same thing we will check for integers. So let's take any two integer. Suppose I am taking 5 and minus 2. Add it. 5 plus minus 2, it will be positive 3. What about minus 2 plus 5? This will also be positive 3. So we can say 5 plus minus 2 and minus 2 plus 5 both are same, that is positive 3. So addition is commutative. For integers. Same thing we'll check for subtraction. 5 minus 2. This will be 7. What about minus 2 minus 5? This will be negative 7. Now we can say 5 minus 2 is not same as minus 2 minus 5. So subtraction is not commutative for integers. Okay. Now let's check for multiplication. 5 into minus 2. It will be minus 10, right? What about minus 2 into 5? this will also be minus 10. So 5 multiplied by minus 2 is same as minus 2 multiplied with 5. If I am changing their places, answer is same. So multiplication is commutative for integers. Now let's check for division. 5 divided by minus 2. It will be 5 by minus 2 I can write. Right? Now minus 2 divided by 5. This will be minus 2 by 5. 5 by minus 2 and minus 2 by 5 both are not same. So I can say 5 divided by minus 2 is not equals to minus 2 divided by 5. So division is not commutative. And now commutative property for rational number. Let's take any two rational number. Suppose I am taking minus 6 by 5 and minus 8 by 3. Okay, now add it. Minus 6 by 5 plus minus of 8 by 3. Add this to 15 minus 18 minus 40. So we will get minus 58 by 15. Now change their place and check it. So if I will write minus 8 by 3 at first and then minus 6 by 5, we will get 15 minus 40 minus 18. That is minus 58 by 15 only. So when I am changing the place, both the answer is same only. So yes, addition is commutative for rational number as well. Let's check for subtraction. Minus 6 by 5 minus 8 by 3. Subtract it. You will get 15 minus 18. Here positive and 40. So we'll get 22 by 15. Now change their place. At first I am writing minus 8 by 3 and then minus of 6 by 5. It will be 15 minus 40 and here positive 18. So we will get negative 22 by 15. So positive 22 by 15 and minus 22 by 15. Both are not same. Here we are getting our answer in like as positive fraction and here we are getting negative fraction. Both are definitely not same. So we can say subtraction is not commutative for rational number. Clear? Now check for multiplication. Minus 6 by 5 into minus 8 by 3. Either cancel it and then do the multiplication. We will get 16 by 5. What about minus 8 by 3? Multiplied with minus 6 by 5. Multiply it. You will get 16 by 5 only. So we are getting, when I am changing the place, I am getting same answer. So yes, multiplication is commutative for rational number. Now check for division. Divided with minus 8 by 3. Now change it to multiplication and write the reciprocal. So we are getting 9 by 20, right? What about when like I'll change the place? What will happen? 8 by 3, negative 8 by 3 divided by minus 6 by 5. Divided, we'll get minus 8 by 3 into 5 by minus 6. So we are getting 20 by 9. 9 by 20, and 20 by 9 is not same. Okay, so we can say division is not commutative for rational number. And now we will discuss associative property, that is our third property for whole number. Let's take any three whole number. Suppose I am taking 7, 2, 5. Now I want to add this 3. So 7 plus 2 plus 5. Suppose I want to give bracket here in front of 2 and I want to keep this 2 and 5 together. What will happen? According to Bodemas, if we will solve it, we will get 7 plus 7, that means 14, right? Now I am going to add this 3 number again by just giving the by just slightly changing the pattern. So if I will keep this 7 and 2 together and then will add 5, what will happen? 9 plus 5, that is 14 only. So we can say from the first case as well as from the second case, we are getting the same answer. So when we have to add 3 number, 7 plus 2 plus 5 is same as 7 plus 2 and then plus 5. Okay, so this is called associative property. In the first left side, you can see 2 is getting associated with 5. And in the right side, you can see same 2 is getting associated with 7. And if after just doing this slight change, if we are getting the same answer, then we can say addition is associative. Or for any 3 variable, that is A, B, C, if I can write A plus B plus C is same as A plus B and then plus C, then addition is associative. Same thing we'll do for subtraction. So 7, 2 and 5, same number I am taking here. So 7 minus 2 minus 5, what we'll get? 7 minus 3, and this will be positive 10. What about 7 minus 2 at first and then minus 5? We will get 5 minus 5, that is 0. So 10 and 0, we are not getting same answer. So subtraction is not associative. Okay, same thing will apply for multiplication. So 7 into, if at first I'll multiply 2 and 5 and then will 7, what will happen? 7 into 10 and it will be 70. What about I'll change the pattern, that is 7 I will multiply at first with 2, then I will multiply with 5. The answer I will multiply with 5. It will be 14 multiplied with 5 and will get 70 only. So we can say multiplication is also associative for whole number. So 7 into 2 into 5 is same as 7 into 2 into 5. What are we doing in this associative property? We are not doing anything like a rocket science. We are just changing the their pattern, like 7 to 5. I want to multiply this 3 number. Now at first I want to keep 2 numbers together and then I am taking out the answer. Then in the second case I am keeping another 2 together and I am taking out the answer and checking if both are same, then I will say that property, that operation is associative. If not same, then I'll say that operation like multiplication or subtraction, subtraction is not associative. Clear? Similarly, we'll do for division. So if I will do 7 divided by 2 divided by 5, what we'll get? We will get 7 divided by 2 by 5 or 7 into 5 by 2. And this will give us 35 by 2. When we will change the thing bracket, we'll place it at first. What will happen? 7 divided by 2 at first and then division sign 5. So it will give us 7 by 2 into 1 by 5 is equals to 7 by 10, right? So this 35 by 2 and 7 by 10, these two are different. So we can say division is not associative. So addition and multiplication, these two are associative, and subtraction and division are not associative. And now we will do the same thing for integers. Let's take any three integer. I am taking -2, 3 and -4. Add it. -2 plus 3 plus -4, and we will get -2 -1, that is -3. When we'll keep this 3 with this 2, what will happen? We will get 1 -4, that is -3. So from both the cases we are getting -3. Then addition is associative for integers. Here I am writing yes, it's associative for integers. What about subtraction? -2 minus 3 minus -4. What will happen? -2 minus 7, that is -9. When we'll keep this 3 with this 2, what will happen? -2 minus 3 at first, and then minus of -4. This will give -5 minus +4. When we'll open the bracket, and we will get -1. So -9 we are getting from the first case and -1 from the second case. So no subtraction is not associative for integers. Same thing we'll check for multiplication. -2 multiplied with 3, multiplication with -4. Okay, multiply this, we will get -2 -12, that is 24, +24. Now change the bracket, like keep this 3 with this 2 at first, like this, and then multiply this -4. We will get -6 multiplied with -4, which will give +24 only. So here we are getting +24, here also we are getting +24. So yes, multiplication is associative for integers. Now check it for division. -2 divided by 3 division with -4, we will get -2 divided division sign 3 by -4, and then we will change it to multiplication sign. It will be -4 by 3, and we will get 8 by 3. What will happen when we will change the pattern? -2 divided with 3 at first, and then division sign -4. So we will get -2 by 3, and we can write it as 1 by -4. So 2 times 4, we will get 1 by 6 only. From the first case we are getting 8 by 3, and from the second case we are getting 1 by 6. So we can say division is not associative for integer. It's not associative. So addition and multiplication is associative, but division and subtraction is not associative. And now we'll do same thing for rational number. So suppose I am taking 3 rational number, that is -2 by 3. First one as -2 by 3. Second one as 3 by 5. And the third one as minus 5 by 6. And at first we'll check for addition. After doing addition, according to associative property, what we got? The first answer is minus 9 by 10 and the second one is also minus 9 by 10. So we can say yes, addition is associative. Similarly, for subtraction, if we'll get the first one as minus 63 by 30 and the second one we are getting as minus 13 by 30, which is not same. So it's not, subtraction is not associative for rational number. Similarly, for multiplication, we got 1 by 3 for the first one and for the second one also we got 1 by 3 only. So multiplication is also associative for rational number. Now for division, we are getting from the first case we are getting 25 by 27 as the answer, and from the second case we are getting 4 by 3. So we are not getting same answer. So we can say division is also not associative for rational number. And now we'll discuss our last property, that is distributive property. So suppose I am taking three variables, that is A, B and C. So according to this property, A into B plus C, we can write it as A into B plus A into C. Or if there is subtraction inside the bracket, like B minus C is there, then similarly we can write A into B minus A into C. So what this property says, if A is sitting outside and B and C is inside the bracket, then we can distribute this A with B and this A with this C as well. We have to distribute it with each and every term sitting inside the bracket. That's why I have written A into B, then A into C. This A is meant to be for B and it's for C as well. That's why it will be A into B, A into C. This is called distributive property. You can apply this property for any a whole number or integer or any rational number. Let's take three rational number, 1 by 2, minus 2 by 5 and 7 by 3. Suppose we have to do the multiplication, like 1 by 2 is in multiplication with minus 2 by 5 plus 7 by 3. Rather than solving according to BODMAS, what we do? We solve bracket at first and then we do the multiplication. But here, we according to distributive property, we can multiply at first. We can do this one, like 1 by 2 into minus 2 by 5 and 1 by 2 will be in multiplication with 7 by 3 as well. And then multiply this one at first, we'll get minus 1 by 5 plus 7 by 6. So when we'll subtract it, when we'll solve it, we'll get 30 minus 6 plus 35, 29 by 30. And now problem solving time. We have discussed four properties: closure property, commutative property, associative property and distributive property. Now we will apply this property for solving this question. It's normal simplification, but we will solve this one with the help of the property now only we have discussed. So 2 by 5 multiplication with minus 3 by 7. Okay. Now this minus 1 by 6, I can write it as plus minus of 1 by 6. Okay. Into 3 by 2 plus 1 by 14 into 2 by 5. Now here we can apply commutative property. Suppose this one is A and this one is B. So A plus B is equals to B plus A for rational number. So we can apply commutative property here and we can write 2 by 5 multiplication with minus 3 by 7 plus 1 by 14 into 2 by 5. I am writing this term here, and minus 1 by 6 into 3 by 2. What I did, I have applied commutative property. A plus B is equals to B plus A for rational number. Now, here you can see clearly that 2 by 5 is here and 2 by 5 is here. So, we can take out 2 by 5 as a common factor. So, 2 by 5 I am writing outside, and inside the bracket minus 3 by 7 plus 1 by 14. Okay, what I am applying, or you can say reverse of distributive property I am applying. If there is A outside the bracket and B plus C inside the bracket, what I can write? I can write it as A into B plus A into C. So this one we are having, and we are writing this one. Reverse of distributive property, or I am taking out just common factor. So the last term will be as it is, into 3 by 2. Now solve this, the bracket one at first according to BODMAS. Now we'll solve the bracket at first. Okay, so 2 by 5 into, here LCM will be 14, 7 2 times 14, so it will be 6, and plus 1. Here minus 1 by 6 into 3 by 2. What we'll get here, I am writing. So we are getting 2 by 5 into minus 5 by 14 plus minus 1 by 6 into 3 by 2. Now again BODMAS says solve multiplication at first and then addition. So we will solve this multiplication and this multiplication at first. So solve it. 5 and 5 will cancel each other. 2, 7. We'll get 1 by 7 here, minus 1 by 7, and here we'll get minus 1 by 4. When we will open the bracket, it will be minus 1 by 4. What will be the LCM? 28, right? So minus 4 minus 7. So our answer will be minus 11 by 28. It was easy. We just applied the property. Now only we have discussed the property, and it like our work became so simple, right? Now role of 0. What is this? Suppose if we'll add 0, this 0 is called additive identity of whole number, integer, or rational number. What is additive identity? It means when we will add 0 with any number, like suppose I am taking first, I am taking for whole number. So if I will add, if I'll take any whole number like 5, and if I'll add 0 with it, then the answer will be 5 only. So what does it mean? It means the identity of 5 is not changing. Previously it was 5, now also it is 5. So that's why this 0 is having a name called additive identity. Okay. Similarly, if we'll do the same thing, for integer, suppose I am taking one integer minus 24. If we will add 0 with this minus 24, our answer will be minus 24 only. So what I am getting? After adding 0, identity of minus 24, it was earlier minus 24 and now it is also minus 24. So identity is not changing. So we can say 0 is the additive identity for whole number, for integer, or for rational number. Suppose you will take any rational number like 5 by 6, and if you will add 0 with it, our answer will be 5 by 6 only. So identity of 5 by 6 is not changing. Earlier also it was the number, it was a fractional number 5 by 6. Now also it's a fractional number 5 by 6 only. So it's same. So 0 is called the additive identity for whole number, integer and rational number. Now we know what is 0. 0 is the additive identity. Now what about 1? 1 is the multiplicative identity. When we will multiply 1 with any whole number or integer or rational number, the identity of number will not change, or in simple word, the number will not change. It will be the same number. So suppose I am for whole number, suppose I am taking one whole number as 24, and if I will multiply 1 with it, we will get 24 only. So identity is not changing, but here it's multiplicative identity. Okay, if I am multiplying 1, we are getting the same number. So same thing will follow for integer. Suppose I am taking one integer, that is minus 32, and if I will multiply 1 with it, our answer will be minus 32 only. That's why it's having its name called multiplicative identity. Same thing we can see for rational number. If we are taking one rational number, that is 21 by 52, and if you will multiply 1 with it, you will get 21 by 52 only. So 1 is the multiplicative identity. And now negative of any number or additive inverse. Here let's take any integer. Here we'll not take whole number because whole number can't be negative. So if I am taking one integer, that is 24, positive 24 or 24, negative of this one, its negative will be minus 24. Okay, what I am doing? I am writing the same number, that is 24, and just changing the sign, writing it with opposite sign. If I am having minus 24, what will be the negative of minus 24? Negative of minus 24 will be positive 24. So what we have to do? We have to write the same number with opposite sign. How this positive 24 came? If I will do negative of minus 24, at last we'll get positive 24 only. So from here it's coming. We can say it's a negative of minus 24, or it's a additive inverse. What is additive inverse? Additive inverse is a number minus 24 we are having at first. For this case, additive inverse of minus 24 will be plus 24. It's a number which I will add with minus 24 and which will give the result 0. Okay. If you want to write additive inverse of 5, it will be minus 5. Any number which will be added to 5 and will give result as a 0. Similarly for rational number, we can take what will be the additive inverse of 1 by 2. So additive inverse of 1 by 2 will be minus 1 by 2. Okay. Same fraction with opposite sign. And that fraction, if you will add with the previous fraction, you will get 0 as an answer. And now reciprocal or multiplicative inverse. What is reciprocal or multiplicative inverse? Suppose I am taking one rational number, that is 2 by 5. So reciprocal or multiplicative inverse means what should be multiplied with this 2 by 5 so that we will get result as 1. So if I will multiply 5 by 2 with this 2 by 5, then 5 and 5 will cancel each other and 2 will cancel each other. At last we'll get 1 as a result. So what is reciprocal or multiplicative inverse? This 5 by 2 is the reciprocal of 2 by 5. What does it mean? We will just reverse the fraction. If we are having like any integer or whole number like 24, what will be the reciprocal of this one? It will be 1 by 24. Because 24 means 24 by 1, and if we will just reverse it, if we will write the reciprocal fraction, we will write denominator as a numerator, numerator as a denominator, and this is the only like fraction which we will multiply with 24 and will get result as 1. So 1 by 24 is the reciprocal or multiplicative inverse of 24. What is the reciprocal of minus 25 by 72? Reciprocal of this minus 25 by 72 will be 72 by minus 25. Here we will not change the sign. Here we will write the, like with same sign, we will just write the reverse reciprocal fraction. We'll write denominator as a numerator and numerator as a denominator. That's it. That much we have to change. And if we will multiply this one with each other, we'll get 1 as a result. So what is multiplicative inverse? Which means any like a fraction which will multiply with the given fraction and we will get the result as a 1. That's what the meaning of multiplicative inverse or reciprocal. And now we'll discuss how to represent any rational number on number line. So we know how to represent any integer on number line, but here we'll represent any rational number. So let's take one example. Suppose we need to represent 5 by 4 on number line. So at first see, this 5 by 4 is a positive fraction. So it will go to the right side of 0. Okay. So we need to go here. Now from 0, here I am writing 1. Here I am writing 2. Now I want to divide from 0 to 1 in 4 equal parts. Since our denominator is 4, so I am going to divide it in 4 equal parts. So this one is first part, second part, third part and fourth part. Similarly, we'll divide from 1 to 2 in 4 equal parts. Second, third and fourth. Here our first, since I have divided it in 4 equal parts, the first one will be 1 by 4. Second one will be 2 by 4. Third one will be 3 by 4. And the fourth one will be 4 by 4, which means 1 only. Okay. Now fifth one will be 5 by 4. So where this 5 by 4 will lie? It will lie here. Okay. At this point. And now if we are having any negative rational number like minus 3 by 4, and if we have to represent this one on number line, how we will represent? Since it's negative rational number, it will lie on the left side of 0. So 0, here minus 1, here minus 2. Now we are having our denominator as 4. So we will divide from 0 to minus 1. We will divide it in 4 equal parts. So first part, second part, third part and fourth part. Now we need to represent minus 3 by 4. The first will be minus 1 by 4. Second one will be minus 2 by 4. And third one will be minus 3 by 4. So where it will lie? It will lie here at this point. And now we'll solve one problem. Suppose our question is find any two rational number between minus 3 by 2 and 5 by 4. So between these two given rational number, we need to find any two rational number. So suppose I am taking this one as a minus 3 by 2 and here I am writing 5 by 4. Now Suppose this one is A and this one is B. If we have to find the middle point of A and B, what we do? We do A plus B by 2. Similar concept we will apply here. So, minus 3 by 2 plus 5 by 4 divided by 2. Do it. LCM will be 4. Minus 6 plus 5. Okay. And here it will be divided by 2. I can write it as 1 by 2. So, minus 1 by 4 into 1 by 2, which will give us minus 1 by 8. So, we got exact middle point of minus 3 by 2 and 5 by 4. So, it will be, here it will lie, minus 1 by 8. Okay. Now, we are searching two rational number in between these two given rational number. So, another rational number we can find either midpoint of this one and this one, or midpoint of this one and this one. So, let's do midpoint of this one and like minus 1 by 8 and 5 by 4. A plus B divided by 2. LCM will be 8 minus 1 plus 10 divided by 2. I can write as 1 by 2. So 9 by 8 into 1 by 2, we will get 9 by 16. So where it will lie? It will lie exact midpoint of this one. So here it will lie 9 by 16. Clear? We found two rational number between minus 3 by 2 and 5 by 4. What are those? First one is minus 1 by 8 and second one is 9 by 16. If we need to find more than three rational number, then we can go ahead for finding midpoint of this two. Or if we want to find more, then similar process we need to repeat. I hope the whole concept on rational number is clear to you. Thanks for watching the video.